Forget the robots you see in factories or movies. Today, we're going behind the scenes to meet the secret teachers, the hidden machines that make every single advanced robot possible. Yeah, you heard that right. The surgical bot that saves lives, the rover exploring Mars, the AI running a massive warehouse. They all started here. They all share a secret origin story that begins with the very robots we're about to show you. And this isn't some niche thing. Right now, there are over 2 million of these unsung heroes working quietly in classrooms and university labs all over the world. They're the training grounds, the sandboxes, the secret weapon behind every big leap we make in robotics. So, what are they really? What is it that separates these learning platforms from the slick, commercial machines they help create? Well, it really boils down to one thing: their mission. See, these robots aren't built to be the fastest or the most profitable. They're built to be understood. Every single wire, every sensor, every line of code is an open book, designed for one reason: to let a human learn, to let a researcher ask, what if, and to push the absolute boundaries of what's possible. Okay, let's get into it. We're going to count down the 10 most important robots that are building our future. It's a journey that starts with a kid's very first line of code and ends, well, it ends at the final frontier. Kicking us off at number 1 is a robot that can teach a 5-year-old the core logic of programming before they even know their multiplication tables. Think about that. With simple drag-and-drop blocks on a screen, a kid is commanding a real physical machine. They're learning computational thinking, how to break down a huge problem into tiny, logical steps. This is where that first spark gets ignited. Coming in at number 2, we've got the absolute backbone of pretty much every school robotics club on the planet. You've probably seen these Lego-style kits, but they teach something way more important than just building. They teach the entire engineering design process. You build it, you test it, you watch it fail, and you try again. This is where that spark becomes a real hands-on skill. All right, for number 3, we're stepping into the university lab. This robot has 0 secrets. Its hardware designs are published online, and it runs on open source software like ROS, the robot operating system. Just think of ROS as the universal language for robots. It lets researchers everywhere see, change, and share everything they do. That means a breakthrough in a lab in Tokyo can be instantly tested and improved by a team in California. It is global collaboration at its best. Number 4 is where things start to get, well, a little more personal. This humanoid robot isn't designed to do a job. It's designed to understand us. By studying how we react to a machine that walks, talks, and even shows emotion, researchers are literally writing the rulebook for how humans and robots are going to get along in the future. Teaching one robot to be smart is pretty impressive. But wait till you see number 5, where they teach hundreds of robots to work together as a single mind. This is the Swarm. You have all these simple little bots, and individually, they're not that smart. But when they follow a few basic rules together, they create this incredible, complex, intelligent behavior, just like a flock of birds or an ant colony. It's a mind-blowing lesson in collective intelligence. Okay, so we've had robots that work alone and robots that work in huge groups. But what if a robot didn't have any hard parts at all? Get ready for number 6, the Soft Robot. This thing has no bones, no metal frame. It's made of flexible silicone and powered by air, which lets it do something that's basically impossible for a normal robot: gently pick up a raw egg without crushing it. This is robotics inspired by nature, and it's paving the way for machines that can safely work right beside us. Now, number 7 is the true workhorse of any modern robotics lab. This machine combines the 2 hardest challenges in robotics: moving around and actually doing something. The mobile manipulator learns to navigate a cluttered room using lasers, find a specific object with its camera, and then pick it up with its arm, all by itself. You're looking at the direct ancestor of the future robot assistant in your home. You ever wonder how consumer drones have gotten so ridiculously good so fast? Well, you can thank number 8, the Aerial Research Drone. This is basically a flying laboratory. It lets researchers test their craziest, highest-risk flight programs without worrying about crashing $1 million piece of equipment. That cool Follow Me feature on your drone? Yeah, it almost definitely started its life right here. Okay, this next one completely changes the game. Number 9 isn't controlled by code or a joystick. It's controlled by human thought. Using what's called a brain-computer interface, this platform literally reads a person's brain signals, allowing someone, often a person with paralysis, to command a robotic arm just by thinking. This is where robotics becomes a true extension of the human mind. And if you thought that was happening in labs on Earth, our final robot isn't even on this planet. For number 10, we're heading up to the International Space Station. These little free-flying robots are testing how to navigate on their own in zero gravity, an environment that is absolutely impossible to recreate on Earth. It's the ultimate stress test, proving that for robotics, there are literally no boundaries. So, from a child's first toy all the way to an astronaut's flying assistant, what's the one thing, the one thread that connects all of these incredible machines? Here's the most crucial point. None of these robots are the final product. They aren't built for profit, they aren't built for speed. Their one single purpose is to advance human knowledge, whether that's for a 5-year-old learning to code or a PhD researcher pushing the very edge of science. Every single breakthrough starts right here, in the classroom, in the lab, and in the human imagination. If taking a look at this secret world of teaching robots kind of blew your mind, do us a huge favor and hit that like and subscribe button. Because in our next explainer, the robots are coming home. We are diving deep into domestic robots, the machines that are about to enter our kitchens, our living rooms, and our lives. Trust me, you're not going to want to miss that one.
I'm Synera, and I just want to say a huge thank you to every single one of you for spending your time with us today. It genuinely means the world. If you enjoyed this, do me a favor, hit that like button and subscribe so you never miss what we put out next. We've got so much more coming your way, and I can't wait to share it with you. Until next time, stay curious, stay inspired, and I'll see you in the next one.